Jupiter is over 700 million kilometers from Earth, a world of storms, radiation, and ever-shifting clouds. But how do we study it in such incredible detail? In this final episode of the Infinity Beyond Jupiter series, we reveal the tools, missions, and brilliant methods scientists use to explore a planet they can never touch, and the surprising technologies that let us see beneath its turbulent atmosphere. First, let's start with the challenge. Jupiter has no solid surface. Its surface is a dense layer of clouds composed of ammonia, ammonium hydrosulfide, and water, with cloud decks that extend hundreds of kilometers downward. These thick cloud layers block visible light and constantly swirl in chaotic patterns. Studying what's below the top layers requires specialized instruments that can peer through storms, orbiters, and flybys. Several spacecraft have visited Jupiter, each providing new ways to see the unseen. Pioneer 10 and 11, first spacecraft to fly by Jupiter in the 1970s. Voyager 1 and 2 provided detailed images of Jupiter's atmosphere and moons. Galileo Orbiter, 1995 to 2003. The first to orbit Jupiter and drop a probe into its atmosphere. Cassini and New Horizons used Jupiter for gravity assists and captured valuable data. Juno, 2016 present. Currently in orbit, providing the most detailed insights ever. Galileo's atmospheric probe, one of the most daring missions, was Galileo's atmospheric entry probe in 1995. It plunged into Jupiter's clouds, lasting 58 minutes before it was destroyed by pressure. In that short time, it measured temperature and pressure gradients, chemical composition, including water vapor, wind speeds over 600 km/h. These direct measurements validated and calibrated remote sensing instruments used today. Juno's suite of instruments. NASA's Juno spacecraft is a scientific marvel. In a highly elliptical orbit, it avoids Jupiter's deadly radiation belts while flying close to the cloud tops every 53 days. Key instruments on Juno include JunoCam, a visible light camera for public engagement and weather tracking. Microwave radiometer, MWR, peers deep into the atmosphere to detect water, ammonia, and temperature profiles. Gravity, science instrument, uses Doppler shifts to map Jupiter's internal mass distribution and support the diluted core theory. Magnetometer, measures Jupiter's enormous magnetic field with extreme precision. Jade and Jedi, analyze particles and auroras. MWR in particular allows scientists to see hundreds of kilometers into the planet, revealing hidden weather patterns, vertical cloud structures, and ammonia cyclones invisible to optical cameras. Lightning and thunderstorms. Jupiter's atmosphere is incredibly dynamic. It contains thunderstorms bigger than Earth itself and lightning up to 10 times more powerful than our own. Juno has captured low-frequency radio bursts emitted by lightning deep within the clouds, helping scientists locate and analyze them. Interestingly, lightning on Jupiter is more common at the poles, unlike Earth's equatorial storms, possibly due to differences in vertical convection and cloud layer structure. Spectroscopy and Earth-based observations. While spacecraft provide direct data, Earth-based telescopes remain essential. Instruments like the Very Large Telescope, VLT, and James Webb Space Telescope, JWST, can use infrared spectroscopy to measure and atmospheric composition, cloud particle sizes, heat escaping from the planet. Even amateur astronomers contribute by tracking storms and auroras, helping coordinate with space missions in real time. Wind speeds and atmospheric modeling. Scientists measure wind speeds on Jupiter by tracking cloud features over time, including the Great Red Spot and smaller vortices. By comparing images taken hours or days apart, software can calculate movement rates and build models of jet streams, shear zones, and turbulent eddies. Juno has revealed multiple cyclones at the poles, arranged in hexagonal patterns, a surprise that's now being modeled in labs on Earth using fluid dynamics simulations. The future of Jupiter exploration. While Juno has extended its mission into 2025, future missions may go even deeper. Europa Clipper. Though focused on Jupiter's moon Europa, it will gather valuable data on Jupiter's magnetosphere and plasma environment. Proposed atmospheric balloons. Long-term floating probes could drift through Jupiter's skies like weather balloons, transmitting real-time data. Submillimeter and radio telescopes. Ground-based tech is evolving to study deeper layers with better resolution. Eventually, AI and machine learning may analyze Jupiter's weather systems faster than human scientists, tracking storm evolution and discovering unseen trends. Final thoughts. Jupiter is more than a gas giant. It's a cosmic laboratory. It challenges engineering. It pushes science. And it continues to surprise. With every orbit, every image, and every byte of data, we get closer to answering the grand question: how do giant planets work? And what do they tell us about the universe? Thank you for joining this 17-part journey through Jupiter. Subscribe to Infinity Beyond and continue exploring, because the universe is only just beginning to reveal its secrets.